Hello, we are continuing our integration series. For those of you who are new here, you can find the link to a playlist which contains all of the videos on this topic in the description down below. Also, today I'll put the link to my previous video because for this integral its structure is the same as the one we did before, so I won't dive into details that much for this one. You can just go to that video and open up the explanation of the process, why we do this or that. It's a definite version of the integral in the previous video, and instead of cosine here we have sine. So we'll do pretty much the same things, except that we'll additionally calculate the boundaries of the integral and the cosine being sine. Alright, so we'll use integration by parts, and please note that this integral can be expressed as definite integral from 1 to e sine of ln of x times 1 times dx, and we'll again use sine of ln of x and 1 times dx in our integration by parts. Alright, we take u as sine of ln of x, then du, let's compute it, it will be cosine of ln of x over x, right? We just multiply this by the derivative of what's inside because it's a composite function, and derivative of ln of x is 1 over x. Next we took, like if u is sine of ln of x, then dv will be 1 times dx and v will be x in this case. Also keep in mind that we want to have the form of uv minus v times du, so we get x times sine of ln of x from 1 to e minus an integral, a definite integral from 1 to e of x times cosine of ln of x over x dx. And now it means that we have, well, first let's directly compute these boundaries. So we have e times sine of ln of e is 1 because e to the power 1 is e, plus we have 1 here, minus 1 times sine of, well, ln of 1, it's by definition 0, right? Because e to the power of 0 is 1. So we have sine of 0 here, minus this integral, two x's they cancel out, so we have integral from 1 to e x times, cosine of ln of x dx. Alright, now sine of 0 is 0 actually, so this simply disappears and we get e times sine of 1 minus, again we can use integration by parts with the same trick as we did before, and this time I'm opening up the brackets so that we can do integration by parts in our head. Keep in mind that cosine of ln of x is the function we'll differentiate later on. We need to care about the function we want to find an antiderivative of. First we just rewrite the cosine of ln of x, cosine of ln of x. Also, for those of you who are new here, we use integration by parts in our heads usually, so that we don't lose any time. In previous videos as well, I think I've mentioned this. It's nothing special, just writing everything directly without using this notation of u and dv. Alright, so we took an antiderivative of dx, which was x. Now we simply subtract the integral from 1 to e of that thing that we found, which is x. We just copy this and then find a derivative of cosine of ln of x, like the other function. So it is what it is. It's minus sine of ln of x over x, right? And dx we have here. I hope everything is clear up to this point. Also, I forgot to mention boundaries here. Since we have a definite integral, in each step we need to consider our boundaries or limits, whatever. So let's clear it up a little. We have e times sine of 1 Then we have minus, again ln of e is 1, so we have minus e times cosine of 1. Then we'll have like this, ln of 1 is 0 and cosine of 0 is 1. So we have 1 here, like the lower limit for this one. It's like inside the brackets it would be minus 1 times cosine of 0, which is 1, so just minus 1, and minus minus turns into plus, so I'm directly writing plus here. It's plus 1. I was talking about this minus here. Okay, and here let's see what happens. Two x's, they cancel out each other, and we have plus, right, integral of definite integral from 1 to e, but we also have minus here, so in the end we are left with the minus sign. So we have minus an integral from 1 to e of sine of ln of x dx. Now it is what we wanted to obtain actually. Now we have an equation which has some things in it, some terms, as well as the integral we want to find. And here it is. So crucially we want to add, like if we say this is some variable a, we want to find this a, and we can add to both sides of this equation a, so we'll have 2a is equal to this expression here, and then that expression will divide by 2 and get the result, which is a that we want to find. Now let's quickly do what I said. Quick note. Now we can move on, and as a result, quick overview, we have this and this in our hands, so we add the desired integral to both sides, and this leads us to the following equation. We have an integral from 1 to e of sine of ln of x dx equal to e times sine of 1 minus cosine of 1, right, plus 1. Great. Now this can already be considered as a final answer. Nevertheless, let's sum it up quickly and write it in a nice way. We have the integral, which is equal to, oh sorry, here we have e, right, yes, we have e times cosine of 1, so it's e times sine of 1 minus e times cosine of 1 plus 1 over 2, and it's our final answer. I'll rectangle it as I always do. So overall, we just use the trick that we can write the expression as this expression times 1 and use integration by parts. Also, the idea here was that we cannot directly find this integral, although it is alternating after some time, so we can just make use of it and evaluate it in a non-trivial way, let's say. Here it is the final overview of what I did. If you have some questions on this exercise or in any other ones, please feel free to write them in the comment section below. See you in the next videos. Bye.